Hey, Jin.
Hey, yeah, I got pinged in the Slack channel, so I figured they might want input, so I just came in. But I don't actually know if some other folks may not be able to meet today, so I'm not 100% sure. Uh,
No idea.
okay.
I assume Michael and Pascal are going to be here in a second.
Yeah, they're on the invite list, so maybe they're just running late, so it's fine. Uh, oh.
Ooh. Mhm.
Hey guys, sorry.
Yeah. All good, all
Hey.
good.
Awesome. For pasta also. So Kamil and David will not be there. They are
Hey.
busy.
Yeah, so we have a company thing in 2 weeks, so I won't be able to make it. But if folks
Um,
want to meet in next week, I can make it also. But that's
Yeah. Let's see what we get out of here. I mean, we're totally flexible with this, right?
yeah.
I just
Now we have
like
another year to get specification on the Lizard.
no. My internal goal is still to get like it's really polishing work now, right?
Yeah.
Um, and I also try now every week to have very focused items we can look at and then decide is that the way we want to go? Okay, let's jump right in, right? Wait, 1 second. Okay. Okay, let's get it started. So let me remind you, by being here, we all agree to the GraphQL Spec Membership Agreement, the Participation Guideline, the Contribution Guide, and the Code of Conduct. Also, all meetings are recorded and published to YouTube, and we may or may not use LLM tools to analyze. And with that, let's do a quick round of introduction. My name is Michael Stipe.
I am Pascal.
Hi, I'm Mr. Chin from Apollo.
Yeah, I'm Derek.
Awesome. So we have, I think, four things on the agenda. As I mentioned before, very, very focused. So let's start. Before we start, does anyone have something else for the agenda? Then we can fit it in.
How is the reception at the GraphQL conf? How people are reacting? Because I think you were talking about the composite
Yes,
schema stuff, right? But I was
but
just curious. This is like off topic, but
yeah. And so in general, there is like in the talks. So in the chats that we had in between talks, was very well received. Also, I think that we call it now GraphQL Federation, as a title is connecting with people. In general, there was like a very positive vibe around that. In general, the conference, um, I would say, was unfortunately not so full.
and the
And
timing was also pretty bad for Meta, right? So yeah.
yeah, but it was like the meta people on the second day basically weren't allowed to come. So it
Yeah.
was a bit negative vibe. I think Amsterdam, just a couple of months before the
Mhm.
GraphQL was much better. I don't know, Sachin, were you in Amsterdam?
No, I wasn't at Amsterdam. So.
Yeah, I was in Amsterdam like in the fall last year.
Yeah.
I think that was a pretty nice vibe there. But
Yeah,
yeah.
and it's also one thing which was a bit unfortunate is that the venue where we were at in this year was bigger. At least the main the keynote room was bigger than the venue that we had in Amsterdam.
Gotcha.
And there's nothing worse than having too big of a room for too little people, right?
Yeah.
Yeah.
So even I would say I don't know what the exact attendance, but it felt a lot worse than it was just because there was more people or room
Just
for
the
more people.
visual thing that it looked like, yeah. Okay.
It was also long rooms, and in Amsterdam it was wide rooms.
Hmm.
So even if there's little people, they are spread across the whole room. Whereas if you
Yeah.
have a long room, then there's,
Gotcha.
whole rows without people. So that's a problem. But
Yeah,
anyway,
but I got like there were two other larger companies that came over and said they have their own implementation
Mhm.
of this specification. Then there is Fedi. I don't know if you saw that from Andy Mark.
Yeah, I saw that again, Andreas. Yeah, did
So
that.
there
Yes.
are now, including Fusion 4 implementations, and there is also interest from other open source um, maintainers.
Nice.
So in general, a good vibe around it. I would say in Amsterdam when I did the talk with Martijn, like the room was pretty full.
Hmm.
Uh,
Yeah.
in Now in San Francisco, we had the ballroom, and the field just empty
Mm,
because it was the big room.
gotcha.
But anyway,
Yeah.
um, yeah. So out of that, also came a lot of discussions around these things that I've now picked up. Um,
Yeah,
um,
Andreas did the like a pretty nice write down on the issue, like the stuff
yeah,
he encountered. I think those are good points there.
yeah, yeah. It's also like we see that now. Like we started work on an Apollo Federation adapter that basically makes the Apollo subgraphs composite schema compatible. And that's where we also run into issues where it is not where we have compliance difference or merge differences. And that's also where a couple of these tasks come from. Pascal,
Muted.
still
one
muted.
thing, yeah, sorry. One thing that isn't conference related, but goes into the same direction. We have now more and more people using the Fusion V2, which is the composite schema, fully composite schema compliant. And the feedback that we get from them is also very, very positive. And what's a bit surprising is that as this was a specification which was written over the last couple of years,
Mhm.
the LLMs already understand quite a bit of it.
Yeah.
So as there's a resemblance to so it's able to pick up the resemblance to Federation with the
Mhm.
shareable, so it does this correctly, but it also knows about the lookups. So it kind of figures it out. There's a few things which we see, which happens now. For example, that it really wants to declare a field as shareable, even though that it has a key, and things like it has a lookup and things like this. But we are at the moment discovering these things once they come in, because more and more people are relying on models. And luckily, our whole effort here started a bit before this was such a big boom. So the
Yeah.
content is already indexed. So.
They scanned whole internet and all those things, so that's pretty scary. But yes.
Yeah, it's our collective knowledge. Um, okay, so the first one is just a validation rule. I
Mhm.
think we should just merge it. It's basically a lookup has to have arguments. If it doesn't have arguments, a lookup makes no sense. Like, what does it look up? Um, except if there's opposition, I just will merge it after the meeting.
Yeah, I think the only use case where this the lookups without the arguments would be for like a nested lookups, which we don't really want to do right now.
Yeah,
Hmm.
nested lookups are in the
Yeah.
spec. So
Yeah.
Okay.
So because on that one, if you try to do like name spacing, maybe, but other than that, yeah, I think that's
yeah, but this works anyway because these the nesting, we don't call it a lookup. Just let me quickly go there. So schema, lookups, we have not these. It's not around. There. Again, this is the lookup. This, if you put a lookup directive on something, then this something needs to have at least one argument. That is what the merge rule is about. This is the nesting here, for instance, which would
oh
be
yeah, okay. So this is for like the but in this case, the root query for lookups could not have an ID there, right? Or
yeah. This is not. So what we disallowed is
yeah.
that you have nesting that two lookups can be nested.
Yeah, and they
That
have like different and the
yeah.
arguments messing up. Okay, fair enough.
Yeah, a lookup must always be reachable to at least one path that has no arguments. Okay.
There, there might be a case to be made for singleton objects, potentially, or having a case where a particular subgraph may contribute fields to an object, and that object, but that field is sort of the same across things, though I don't know if that's a common case necessarily. I know
Well,
that
so
singleton objects are.
folks were using like the type name for those singletons, right?
Yeah, there's hacks
Um,
around it essentially. Like,
but it's a
you
very
know,
special case. But
But isn't that what the viewer is basically?
the view
As a pattern, like the viewer is an object, which is kind of a singleton on the query field, for instance.
view is a singleton.
Yeah,
Oh,
you
so
basically.
maybe sorry, maybe example might writing that might help. Uh,
Yeah. So typically we have this viewer pattern in GraphQL. Well, it comes in different shapes, right? Um, um, and this might be across multiple graphs. I don't know if it even needs an endlet. Maybe has a user, uh, and here viewer maybe has uh, recent activity, whatever. And in this case, we would just merge these types, right? And they would be, I mean, they are not
yeah.
entities.
Right, it'd be fine either. It's satisfiable, so it ends up being fine in this case,
Yeah.
right? Even if they don't have like keys or lookups, that's fine. Yeah. Oh, so
But but this is not what you meant with singletons, right?
yeah. Like I mean, the singleton should be accessible regardless of path, I guess is what I'm gonna get. Right? So you might want a singleton lookup to have a field available regardless of the path in which you reach that type, if that makes sense.
So
Like,
basically, in your example, viewer would have a key or something.
yeah,
Like
so folks were using like a type name for like something like that, like for so like
this.
there's like they're not even ID, it's just a type name that's like singleton.
yeah, sorry. In our case, what we've seen sometimes in some subgraphs is that to have singleton entity types, people would just put a dummy type name of type name instead of an empty
Yeah.
ID.
Because
Um,
something is required, right? A
yeah,
Yeah.
yeah,
field is required, so they use the type name. But yeah.
yeah.
Oh, I get. So they can use that in requirements and stuff like that. Or why do they do that?
They would do that for add keys in order. So basically, there's some entities where there's basically only sort of one global instance of the entity, but they all want to contribute different fields to that global instance, and then that global instance to be available at different paths. So in your example here, like this works because there's a single path to viewer, right? But you might want to have
Yeah.
necessarily multiple paths to viewer and multiple places that can reach this sort of global entity. In which case, if that's the case, then you wouldn't necessarily want to like declare it everywhere, right? You want the add lookup there to say that I can always jump to this single instance to get those fields on it, if that makes sense.
Yeah. Okay. Okay, then I have to rethink that if we want to
It's
do.
and to be fair, this is like the singleton pattern. It's very rare,
Yeah, it's not common.
but we did see like some folks try to do that, and their workaround was with like the type names to say, hey, this is the type name. This is
Yeah,
how
that's
you
good.
can identify it. Yeah.
It's a good feedback. Okay, I will dig into that and then
Um, Speaking of singletons, I'm not saying that we should introduce that singleton, but maybe this could be worth a gap and could be worth a spec extension because this thing exists in clients as well. Um, like if you look at what the viewer does in Relay, it's literally normalized as a singleton. Everywhere that you return the type viewer, it's going to be the same object. So with singleton, the client also knows how it can do cache optimization with this. Just saying, like it's not only an issue that we have; it's across the
Right,
stack.
GraphQL too. Yeah, yeah.
okay,
Yeah,
let's do a research on that. Also,
Yeah, the only drawback of that is just this is like another directive uh, to indicate something that could be inferred without like if lookup doesn't have arguments, then it's a
you could
singleton
infer that
kind of
this thing.
implied. But other
Yeah,
than that, I kind of like it like explicitness that this because that indicates intent, right? So
yeah.
if one graph defines it as a singleton, the other one, doesn't have a problem that I have a lookup for with IDs and the other one without the IDs, right? Because that would be problematic.
Yeah.
Yeah,
Also,
also we could then still validate that, right? If we know it's a singleton, then we know there's an
Mhm.
intent. It's not a mistake that you forgot all the arguments there. It's
Yeah.
like intent.
I also don't think this has to be in this specification. I don't know if you've seen Mark's gaps. The graphical auxiliary proposals where you can essentially write an empty file and then say this is now canon. No, I'm kidding. It's not so bad. But everyone can write their own specs for things that they want. And we, for example, already have something like at mock where they defined, or I think Mark defined how a mock at mock directive could work. So even if we say this is too strict for our specification, it can still be a gap, and then it could still be that all the gateways support this, right? So
Or an appendix. But let's first what I meant here, Pascal. It's not that we take it, but that we do a research on where it's how it's useful, right? Hey, Stephen.
Hello.
Since you jumped in, do you guys also use singletons?
Do we use what?
Singletons. I didn't know about them, but there is a thing where entities can be like singletons, and how
Hmm.
Apollo does it is that they define here a key.
This is the
That's right,
workaround.
right?
Yeah, that's right. So when users want to define a singleton, instead of providing a key, they'll just put type name, is what we found in practice, to work around the fact we usually require keys. And that's usually used for
Huh.
defining singleton types. So it is a
Fascinating.
workaround for it. Yeah.
No, we don't do that. Uh, that's interesting. A key type name. Huh. Yeah, I never tried that.
Yeah, it's workaround. It just came up because I was about to propose locking down lookups to
Hmm.
fail if they have no arguments. But if we have
Hmm.
singletons, we have to rethink that.
Yeah, I mean, it has come up before. Occasionally people have asked for that, but it's never been, uh, yeah, it's never been a
Yeah.
problem.
Okay.
Usually, I think what we've recommended when they want a singleton, usually they're just looking for name spacing. And so we just recommend like naming the fields
Yeah.
with name spacing instead.
Yeah. Yeah, I'm going to do a bit of research on it. Also, Pascal said in the clients, there's a recognition of singletons. No. Okay, so this was my 5 minute thing. I thought we get it through in 5 minutes, but no. So let's go to some more interesting stuff, and that is like the merge rules for fields. So there came some feedback that Apollo Federation does field merging more complex than we did in the composite schema specification. In the composite schema specification, we basically say to, or we did say that two field types must be equal for a field to be mergeable. Otherwise, we throw a composition error. Let me actually give you an example there. In Apollo, it's possible that you have, for instance, here a query that returns featured item, where featured item is a union, and then on the second schema, the featured is actually the concrete type product. This also works with interfaces, and it still merges. That's correct, right?
That's correct. That's correct. There has to be an implements relationship between like the supertype and subtype if this occurs, or some sort of like union relationship there. But yeah,
Yeah.
occurs. Yeah.
I tried to tackle this in a order independent fashion, where I set the supertype, the supertype, somewhere we have, uh, so basically we pick the supertype independent, so we pick the field type, with the most compatible supertype. I think it's in the helper that I defined. Least restrictive. This is the other types. I had a good sentence somewhere here. Quickly find it. Fields with the composite return type are mergeable when one of the declared return types is a supertype of all other declared return types. That's it.
That's right. Or at least in Apollo's case, that's what we validate there. There's a little extra stuff around lists and non-nullable, or specifically non-nullable more so than lists, where it's allowed for one of the types to be non-nullable while the other is nullable.
Yeah,
Um,
yeah. I baked this also in.
okay.
Um, this also works for scalars, where we have the example here. Yeah, here you can see,
That's
like
right.
you can
Yep.
float, comes in the nullable type. On the output side, on the input side, it's the reverse, right? The more restrictive will be taken.
Yeah, we need to be more restrictive when type merging on the
Yeah.
input side, but yeah.
Yeah, it's also with lists, right? Depending on how you have lists, the nullability is then combined.
That's right. Yeah, you have to look at each per layer level. I think while you're on while you dive into the list. One thing we don't explicitly do is we don't allow list coercion because I think that's a. Or we don't do a thing where like it's possible. It's true that like in GraphQL when you have a single item, it can be auto coerced into a list, right?
Yeah,
We don't allow
but
that because I feel like that was more buggy than
yeah,
that. But yeah,
but it's also only on the input side. Like on the input coercion in GraphQL, it's allowed to have a single to define a single scalar value instead of the list,
yeah.
and then it's coerced into a list. Yeah, yeah. I
Okay.
also didn't include that
Okay. Nice.
because it makes more headache than.
Yeah. Yeah. Agreed. Yeah. It's more headache to explain, and it's the use case
Yeah.
is there for it. So yeah.
Yeah, just like this makes also like if you have today Apollo Federation and you want to now implement the composite schema on top, like have both flavors possible in the gateway, then like this makes it easier because like the type merging works the same.
Yeah.
Okay, would be good if you guys give it a review, like just go over it if you agree with it, like approve it. Otherwise, comment on the section that you want to have rewritten, and then we can polish it. And then maybe next time we can merge it.
Yeah, we can take a look there. So
Okay, awesome.
So I looked at the PR and the examples, and the text looks good, but I was debating commenting because I just wanted to talk about it here. Is
Yeah.
can can we do without this? Basically, like it seems like it'll add complexity to implementation, and and
So
yeah, do we
So
actually need
so
it?
from the Fusion side, our implementation doesn't allow this at the moment. Like
Hmm.
we have a restrict merging. We ran into this when we added um, backwards compatibility to Apollo Federation.
Hmm.
So for gateways that are Apollo Federation compatible, like the like you couldn't do a mixed composition if we don't allow this.
I see.
You
Hmm.
didn't implement that in your implementation of Federation,
No.
but then it's
Yeah.
also, I mean, you could leave it out, I would argue, in your implementation still.
Should
I mean,
we should we make that explicit in the specification? Like if this is like an optional
yeah.
thing in composition, um, yeah, like say like if you're going to allow this, this is how it works, basically. Uh,
David?
yeah.
Hi, yeah, sorry I'm late. So part of the problem here is that I believe, I'm not sure about Fusion. I talked about it briefly with Michael, but I know that Apollo as of 6 months ago, Hive as of 6 months ago, and also Wondergraph now, um, there is a bug in all composition implementations where it uses the first encountered type as its anchor for the least restrictive type, which means that dependent on the order of the subgraphs, you can actually have composition pass or fail. And I don't care which way we lean. It's just there shouldn't be this gray area where um, uh, the order of either the order of composition never affects it, which it shouldn't, or we just never should allow these kind of disparate typings. And I don't mind which way we lean. I just think there should be some governance there,
is there
which
a
is why
case
I
where,
raised this. Sorry.
sorry, Eric, can you do you have the case specifically around this where the order affects what the merged type is? Or is it
Yeah, so for example, imagine you had an interface that implements an interface and then a concrete type that implements them both. If the father interface, let's call it, or the grandfather interface, if that doesn't come first, composition will fail because it thinks that interface and the concrete type are compatible, which they are, but then it will think that the super interface, the grandfather interface, is not
is not compatible with the interface or the other
because
the
it was not anchored first.
oh, anger
I
first.
can send you a more concrete example later if you.
Yeah, that'll help. The concrete example definitely help for understand what the issue is. But yeah, like it sounds to me like you can always at least decide on some super type if it exists, or like I guess I'm curious if there's a case where you can actually have two things, or a case where the order actually affects um the super type and they're both passing. Because I don't think there's a case where that is today. But I also don't think that the order should affect whether it fails or not, success either. So maybe I might not be understanding the issue completely. So the
Yeah,
example will definitely
this
help.
is of six. Like this is it could very well be that it's been fixed in the interim, but 6 months ago, it would appear that the first kind of because you're comparing two types at a time, I believe, at any one time, two subgraphs at a time. So it would take the first two and then take the least restrictive of those and then compare the next one, and then that would not always be um compatible. Like I need to give you a concrete example for what this is really, but I put a few examples in some of the discussions. There was one with like string and like different variations of a
Oh,
list type with string, And
Okay.
like if you change the order of the subgraphs, it passes, and if you change it, it fails. It's
Okay.
This one, David?
no, this is not this one. No. Um, if in the discussion for today's meeting, I think it's the first one I linked where I mistakenly thought it wasn't in the spec.
Ah, yeah, but this is you mean nullability?
This is just for a scalar type nullability.
Yeah.
The one with the grandfather interface. I don't think. I think I need to produce that example.
Okay. Okay. But so I think, like, I would say that the algorithm is order independent. But like, review it and like all of you. If you find a case where it's not, where we need to make it broader, because um, the type merging here should be order independent, and we should use the most compatible um, supertype, like that encompasses all fields. Otherwise, it must fail if there is none that can represent all. Awesome. And Stephen, like, I mean,
Oh,
we could make a note in there to say that this can be left out if I don't know. Could also be just a decision like in Netflix case, we don't implement this part.
Yeah. Mhm.
I
Is
just
I mean, is
Yes,
this something that is really used? Like, is this important for
it ends up
uh
getting used when trying to evolve subgraphs in a way that doesn't break composition in the interim. Usually, I think that's the common case. It's like
yeah.
if you want to like expand the type's output type to something that's wider, or something that like an interface that implements an object, but in that case, you would have composition fail in the interim if you try to do that. So that's the main
see.
use case that we've had for it. But
Okay.
I do see the issue with the algorithm though in on the Paula side. With I was taking a look at the code more, and I think I see what you're getting at with the issue of incompatibility. It's possible that the order can affect whether it determines it's a failure or not. Or if it encounters the super type first that it needs to, then it's fine. But if it happens later in the process, it can result in a failure. So that is indeed a bug in the current Apollo implementation.
Yeah, I've not seen the I'm not legally allowed to look at the code, so I've never seen it. So
Okay.
I just know that it looks like it uses the first type it encounters as like a sort of an anchor almost.
Yeah. Well, yeah. It sort of it tries to find a super type by going through all the types in one pass. Um, and it's possible that if it happens to encounter two types that were disparate or like that didn't actually match, one didn't implement the other, then it would declare this incompatibility. But it's the later type may be implementing them both, and if that occurred first, then it would cause them to be fine. So there is indeed an issue right now with that code. But like, I can we haven't had someone report that, so it's thanks for the find the the find.
Yeah,
Um
yeah,
but yeah.
yeah.
We can look into that.
And the use case, like, as far I talked also to Kamil on this because I was in the beginning also skeptical about this. But like, if you want to have an evolution path to put a union into a field where you just have a concrete type, then this is the only way you can do it.
Yeah, yeah. It helps evolve schemas more gradually in a way where you have like if you have a lot of subgraphs in your schema and you want to all change them, you can't all coordinate that at once. So it's a strategy basically for that. Um, so that's the main use case. But yeah.
Awesome. Okay, then let's go to the next point. Yeah, so this is also compatibility. We haven't thought about this in the composite schema specification. I merged this, by the way, already. It's more, we can do changes if we need, but what we allowed here is basically in our field selection set map syntax that we specified. You can now have arguments, constant arguments only, because in Apollo's implementation, in the requires selection set or field set syntax, you also have the ability to specify constants. So I ported this also on the composite schemas. If there's agreement, we're gonna leave it like that. Like as a further, like I talked already to Martin a bit more about that. Like further down the road, we can allow some kind of variable syntax to have a context notion there, right? Where you can get other things out of the context, similar to functionality that a proliferation, for instance, has, where it stacks context in the past and you can access it down the line, or even other things. But at the moment, it's just constants.
Yeah, I think that sounds fine. So
Okay, awesome. This, by the way, also works with in lookups then, where you specify, okay, this is part of the key, and here we fill in for this lookup this constant. Anyway, okay. Last thing is a discussion that sparked from David's comments. It's about provides. And like in the group, we always discussed that provides is an optimization and should not satisfy the schema composition. Like the schema should be composable and satisfiable if we just discarded all provides. But there seems to be, David, maybe you can chime in because this is the issue you triggered.
Yeah, sure. So yeah, provide is understood to be purely an optimization, but it is like at least currently possible to have um, some path that is only provide like a path that exists in one place and is only accessible by provides and is not accessible otherwise. So without the provides, you would fail composition, you would fail the satisfiability rule. That is something that I know is currently valid in Apollo and I assume also in Hive. Um, so and to be clear, I'm not saying that I think this should be a case. I just think it's possible that there are enterprises that are relying on this and then would have difficulty were this a strict rule that they wouldn't at least be able to override in some way.
yeah.
I know we have customers that are doing this, for example.
In Apollo's case, when we execute satisfiability, we specifically ignore at provides, so that basically the fields, when you fetch them, have to be fetchable outside of a provides, if that makes sense. So we, at least to my understanding, we currently do treat the at provides as more of an optimization. But if there are use cases, though, where folks do want to be able to provide these in a way that's sort of only uniquely through the provides, maybe worth looking at that. I think the main worry in our case was we were worried about making it harder to debug. These kinds of cases where people actually like we would sort of prefer in that case people actually declare a different type, I suppose, if they're going to do something like that, and that would be the workaround there. If they want something that's actually uniquely gettable through the provides, as opposed to um, making a single path that only goes to the provides, because it becomes harder to sort of reason about the schema, I think, was the worry. Because then you have to think about the provides a lot more when doing that during satisfiability. Um,
Is
but
that a
again,
recent is that a recent change?
no, no, I think that's been there for a while.
Then presumably this is a bug then. If it should always ignore the provides, as in it should always be satisfiable outside the provides. Currently, I understand that is not
Correct.
the case, but I don't believe that is the case. I can give you a concrete example.
That will help, yeah. Concrete example will definitely help there to help understand that. But at least that was the intention of that code. So if there could be bugs, but as to my knowledge, um, we generally don't allow using provides to during satisfiability to satisfy a path.
Yeah, my worry also with provides as a means to satisfy the schema is that it becomes very complex to reason about satisfiability in the schema. And you kind of have like these clusters that you have everywhere that make it possible, but everything becomes very intransparent. So
Yeah,
I don't know if we should change the current understanding of that.
yeah. That's basically our reasoning as well there. At least one of the reasons for why. But yeah,
Yeah. But I mean, like for like this is the thing where backwards compatibility, like schemas that already like have this behavior with customers, could make a decision to support it still, or even or show a warning or whatever in the composition. I mean, like when we on the spec side we are more restrictive, then it also gives more space to implementations to deviate from that. But okay, David, you post a couple of examples in the Slack channel, and then we can pick this up for another discussion.
Yeah, I've actually just pinged you in. There's a thread that I've pinged you in. It's a very simple two schema example that, at least on the Apollo composition that I'm running, which it granted is slightly old, this does pass, and you can see that there's no other way to satisfy query.a. Is that one there, right there at the bottom?
This one.
Yeah, there's no other way to satisfy query dot a, but it's still this passes composition. Again, my only concern is people migrating might encounter this if we have strict ruling that can't be overridden in the satisfiability algorithm. That's literally my only concern. I don't think this should be supported outside of migratory purposes.
Yeah.
Wouldn't the type A be an entity though, right?
I mean, this is like, again, this composes in Apollo, no problem.
Yeah, I don't like
Yeah, the only reason I'm saying because like um if A is not an entity, then kind of like the provides I believe is kind of ignored in most of cases on those, but yeah, it's a good call. And thanks for example.
Yeah, thanks for the report. We'll definitely look into the to look into it to see what's happening there. But yeah, I'm not aware
uh,
of this particular example, so I don't know any more until I look into it. But yeah.
okay, good. But like oh, okay, let's or let's maybe have that discussion asynchronously in the Slack channel, and then if we think we should make any change to the status quo that we have that provides is like just an optimization, we can pick it up later again. But for now, I keep the status quo if nobody's against it.
Yeah, I would vote to keep provides as an optimization.
Yeah.
And in this situation, throw error saying that this is actually, it's not, it's bad query, but I would say we should add the validation to prevent that if those are invalid, but it should be optimization.
Yeah, and again, implementations could deviate from that strictness if they want to support existing customers. Awesome. Okay, that's
Oh,
it. Does
what
anyone have? Uh, sorry.
No, I was looking back at the code for merging type references and going back to the whole merge type discussion. I think I understand now why the code does what it does. So I think basically we don't allow diamond patterns when merging. So you can't have a case where like there's A and one field returns A and one returns B and then some other returns I. I think right now it's only the case that you can have like I think it has implementing support for interfaces implementing interfaces, right? So you should be able to have like A implements B and B implements C and then A implements C, and that should work. Um, but I don't think we have support for like a case where like there are some object types that are or there are the cases where like the object types returned by fields are disjoint in that way, or they have no relationship between them. Um, like as long as there is some relationship between every pair of types, then you'll end up with a super type at the end. So pairwise there has to be some sort of implements relationship. Um,
Mm.
And that should work with that code. But that might be intentional. I have to look back at design docs to see whether that actually is the intentional behavior there. But that is a conscious difference between just saying one type of the super type of everything. Or they're
You're
different
correct,
operations.
but it's possible to change the order of the subgraphs and have something either compose or not compose. That was kind of the thing I was getting at.
Okay, so even with that constraint of everything being pairwise a
Correct.
super type, there's still a case where that, okay, if you could post that, that would be helpful. That would be helpful to understand. Because yeah.
Sure.
Yeah, and on all of these pull requests, if we have new insights and it doesn't work with that, just put a comment on there, and then we can incorporate. Awesome. Does anyone else has another issue that you want to discuss? If not, we can close the meeting early. It was great again. And we have another meeting in 2 weeks. Or if somebody has something next week, we can also look at doing a special meeting then. See you guys.
Thanks. Bye bye.
Bye bye.